So far we had discussed about the physical properties of metal. Now let us discuss about chemical properties. The first one, reaction with oxygen. So here a small activity I am going to explain you. In your chemistry laboratory you can perform this experiment to test whether a metal given to you is metal or non-metal. So here are taken two materials, magnesium called magnesium ribbons and sulfur powder. Now what to do with the magnesium? We'll heat the magnesium, and after heating and after burning the magnesium ribbons, keep inside the test tube. Now add little amount of distilled water in the test tube. Right? Now after that, take litmus paper. Litmus paper available in the chemistry laboratory. General litmus paper used to test whether the given material is acid or basic. Now here, which type of litmus paper you have to take? You have to take red litmus paper. So after adding the magnesium member in the test tube and fill some amount of distilled water in the glass tube, then take the red litmus paper and put inside the test tube and observe what happens. I'll come back to you. Now second, take the sulfur powder in a container and heat it. After heating, you'll get some smoke. Take the powder immediately, put inside the jar and close the jar with the lid. This is called lid. The smoke is inside. Now immediately add some amount of water in the jar. Now again take litmus paper here also. Now this time you take a blue litmus paper and keep inside the jar and observe what happened to litmus and record the observations. Now what you're going to observe is that this red litmus paper changes to blue in magnesium case. The blue litmus paper changes to red in sulfur powder case. Why? Because magnesium and sulfur both are interacted with oxygen. Magnesium is O2 reacted with oxygen become magnesium oxide, and which changes the color of the litmus paper. And here sulfur reacted with oxygen becomes sulfur dioxide, and this sulfur dioxide changes the color of the litmus paper. Generally, the materials which changes litmus paper red in color to blue are called metals. So here magnesium is metal. So you have identified that magnesium material is a metal. So this is happened by metal. So metals always changes the litmus paper from red to blue because magnesium oxide, which is reacted with oxygen, is basic in nature. Now coming to sulfur. So sulfur reacts with oxygen becomes sulfur dioxide. So here it changes blue to red, and the metal which changes blue to red are called non-metals. So sulfur is non-metal. That oxide, sulfur dioxide, it is basically acidic in nature. Acidic in nature. So you got so much information from this experiment. The first information that metals, yes, they react with oxygens. Non-metals also react with oxygen. The metal oxides are basic in nature and they will turn the red litmus to blue. And the non-metal oxides are acidic in nature and they turn blue to red. What's the next chemical property? Rusting of a metal. First of all, you have seen how they are reacting with the oxygen. Now this is rusting of a metal. You have learned a little bit about rusting in your previous class, grade 7. Now, what is rusting? Rusting means a different form of layer formed on the metals and which will change the property of the metal. It's not comfortable or good property of the metal. So, how do we protect from rusting of metals? If you see in your house different metal structures like metal rods to the windows, grills to the houses, all these metal rods and grills are coated with some different colored paints. Why they are coated with different colored paints? Because you take the iron rod, it is coated around it, everywhere of the iron rod with some colored paint. Why it is coated? Because if they are not painted, these metals like iron interact with air and moisture in the air, and that makes the body to rust. So when this is coated, a layer is formed and it is in between the air and the metal, and it protects the metal from the air and moisture so that rusting won't happen. If color paint is come out, if it came out after 2 to 3 years later, it will come out from the metal, then you have to repaint it to protect from rusting. So this is the example given for iron material. This type of rusting happen for many type of materials. For example, take magnesium ribbons. Magnesium ribbons, if they are placed for long time in the air, they become dull. And when you cut them, they become shiny. Now take the next example like silver ornaments, silver statues. If you see and you keep it for longer time in the open air, then what happens? They turn into black. Now take the other example like copper. You can see the copper statues, copper vessels. These are good in nature, but if you expose to air for longer time, again they will change into dull green. But of course, the changing takes time. It's a slow process. It is magnesium changing is fast process. Silver changes to black is a slow process. Iron rusting is also a slow process. So all these metals, if you see, generally they are reacting with the air and some moisture and changing its states. And those states are not favorable states. So you have to protect not to change from state. But if you ask me, show me one metal where should not be happen this type of changes. And the metal should be shiny. And the metal should come for longer years without any defect in it. Yes, you have those metals, and those are gold and platinum. Right. So that's why gold is so expensive. That's why gold is demanding metal everywhere in the world, especially in India. You can't say a single house which is not having gold, because golds are shiny. Golds have long life. Gold cannot interact with the air and moisture and cannot be rusted like the other materials. Similarly, platinum also. Why the gold and platinum is special compared to other metals? Well, simple answer is each and every metal has a specific property with which they will interact with the air components in different compositions and different ratios. That's why some metals are damaging their surfaces, their properties. Some metals are stayed still. So next, chemical property to test whether it is metal or non-metal. This is called reaction with acids. Now we'll take some materials which are some are metals, some are non-metals, and we check the reaction with acids. Take some test tubes like this, 4 test tubes you take. In this test tube, add some iron, pieces of iron, add your copper, zinc and sulfur powder. Now take diluted sulfuric acid. Diluted sulfuric acid, or you can take diluted hydrochloric acid, no problem. Hydrochloric acid, and pour into the 4 test tubes and observe what happens. If you have not found any change in that mixture, then heat the 4 test tubes, gently heat and check. Shake the test tube and check any change that happened. If still they not happened, then add concentrated acids like the sulfuric acid, hydrochloric acid to test tubes. Still check. Now, after something you have observed, then take a matchstick which is burned. You strike the matchstick with the matchbox. Take the matchstick and keep the matchstick, which is burning matchstick, near the test tubes like this. Now, for some test tubes, you hear a pop sound. Hear a pop sound and the burning stops. Why it happened like that? Because the flame which is coming from the matchstick stops because of presence of hydrogen. If you have taken the diluted hydrochloric acid in the 4 test tubes, and if you check this experiment, then you understand that some materials are releasing the hydrogen gas, and because of that the burning of matchstick stopped burning, flames gone. So when the hydrogen gas is released, you have to understand that yes, those materials are called metals. Metals generally react with the acids like hydrochloric acids and release the hydrogen, whereas non-metals are not. Next chemical property, reactivity of metals. This property I am trying to explain you that how fast the metals reacts with the other materials. So some metals reacts very fast, some metals react slow, some metals doesn't react at all. So here that you get to know. To this experiment, in the same chemistry lab, take 5 containers like that, and the first 2 jars add 50 ml of copper sulfate. Third jar add 50 ml of zinc sulfate. Fourth jar iron sulfate 50 ml. Fifth jar again zinc sulfate 50 ml. Add it. After adding, next step, add some zinc granules in the first jar. Shake it. Add iron nails into the second jar. Shake the jar. In third and fourth jar, add copper turnings and shake them. In the fifth jar, add iron nails and again shake the jar and observe them carefully. So we discussed about how to identify metal and a non-metal. What are the physical properties of metal and chemical properties of metal? Now, if I say 4 examples to you: iron, copper, aluminium, sulfur. In these 4, which are metals? By this time you should understand. Tell me. Yes, you are correct. Iron, copper, aluminium, these 3 are metals and sulfur is non-metal. Now let me tell you some examples of uses of non-metals. So uses of non-metals. Of course, we have so many non-metals. In our course of discussion, I am taking the first one, sulfur, and the second one is carbon, and third one is iodine. Sulfur, you know that sulfur used in gunpowders. Crackers, it used in gunpowders. Crackers, fireworks, and matchsticks, and some ointments also. Ointment. That is the usage of sulfur. Carbon, activated carbon. If you take this carbon used as decolor agent, and is also used in water purifications. Nowadays, if you see the water purifies, different company water purifies, they will say that you have to replace the refill after 3 months, 4 months. In that refill, you have carbon component to purify the water. Next, iodine. Many times iodine is used as a medical supplement. So these are some examples of non-metals. Now coming to use of metals. As we know that we have so many metals in nature and we have so many uses of metals also. If you see the iron used in many cases, are used in different structures like creation of doors, tables, stands, rods, rotating stands, chairs, cots. In all these cases we can use iron metal. Iron. Next, if you take copper, already we discussed about the uses of copper. Yes, copper is a good conductor of heat, good conductor of electricity. So in all electrical wires we use copper. In all kitchen utensils we use copper. And copper is also used for making statues. Next, silver. Silver used for like silver foils. They're used in sweets to wrap around the sweets. We use silver. And aluminium. In the railway stations, in the bus stands, if you want to buy a ready-made food, and then if you go to a shop and ask a ready-made food, they will give you. If you see the ready-made packaging food, the packaging food is inside a shiny type of box, and that is aluminum box. Generally, aluminum packets make sure that inside the food are hotter. So used for packaging foods. Now, if you take copper and aluminum mixture, copper aluminum mixture, these are used in coins, making of coins, making of medals, making of statues. If you take the combination of iron and zinc, those are used for making long sheets, which are used in different purposes in the construction areas. Now, if I go to the agriculture, there is a limit of usages of metals. For all different types of tools we use in agriculture are made of metals only. So not only agriculture, if you go to the aerodynamics industry, aeroplanes, making of aeroplanes, we use metals. Satellites, we use metals. So each and every area metals are spread and they are helping us to create so many types of tools and making our life easier thanks to metals.